Hey everybody, it's Friday afternoon. The assessment questions have just dropped on Microsoft Teams, and so I'm going to do a quick video to show you how you can access the assessment questions and a reminder of where the assessment question guidelines can be found and what I'm looking for exactly when you submit your assessment question. Right now, we are in my Microsoft Teams application installed on my computer. Remember, if you're using the Chromebook, you want to be using the web browser application. Let's just go into Physics First Hour. I had a bunch of bell activity go off right as the assessment questions were posted. The activity feed shows me something new in one of my teams. So, like in Physics First Hour, the new thing that posted that I was alerted about was the assessment question that's posted right here. It shows me the due date, it shows me what time it was posted, 2:30 p.m., and I can click View Assignment to immediately go to that assignment in my Assignments tab. Once I'm in the Assignments tab, it's going to show me a description of the assignment and any stuff that is actually accompanying the assignment, like an attachment. I'm going to click on Student View so we see what you see. Notice we have a due date up here, August 16th, that's Sunday at 11:59 p.m. It closes at August 16th, 11:59 p.m. So that means that you won't be able to submit your work after that deadline. It's a hard deadline. Those are the rules for our assessment questions and lab reports. If you miss the deadline, you have to request a reassessment or a lab revision. Total number of points are here. The rubric is there, but we already talked about the rubric in class, and it's in the assessment question guidelines portion of our class notebook. Instructions are here. See the attached assessment question. That's this guy, where my mouse is. Follow the assessment question guidelines when answering and formatting your questions described in our class notebook. Let's click on the reference materials, or the attachment. That's what the actual assessment question is. When I click on it, it'll automatically open within Teams, but we can also download it, open it in the browser window, or whatever. Here we are, we've opened the assessment question within Teams. Make sure you can zoom in and zoom out. I can select a particular zoom size, let's go 125%, and I can scroll up and down. If I need to get a better look at something like a graph, let's zoom in more, to maybe 200%. We have other options too, and this is just a single page right there. I'll tell you the unit and the topic. For some units, we'll have more than one assessment question within the same unit. For our Unit 1 in graphing in physics, this will be the only assessment question for Unit 1. Let's go back. We're looking at the same assessment question assignment that was posted at 2:30, but I have 3 dots over here, which gives me more attachment options, more things to do with this attached assessment question. Whenever you see the 3 dots, remember to click on it and see what they do. What's this do? Open in Teams, that's what we just did. Open online, that'll probably launch a browser window with it, or download. Let's open online. Now it's opening the question, which is a PDF file, within my web browser of choice, the default web browser. I can do the same stuff, zoom in, zoom out, scroll around, rotate it, whatever. You could also download it and open it on your computer in offline mode. So that's how we can get to the assessment question. Let's go back to Physics First Hour team real quick. There's the assessment question at the bottom of the stream because it's just posted. But maybe you don't see it in the stream, or some other posts have popped up by, I don't know, Sunday. I don't think anybody's going to post anything over the weekend, but I can go to the Assignments tab at the top. As a teacher, I can see this view of what assignments have been assigned, and as a student, you should also see what assignments have been assigned and whether you've turned them in or not. The Flipgrid and Student Devices survey, you don't have to worry about turning in. I was mostly just testing out how to use the Assignments tab, but all of our important stuff that's for a grade will be in the Assignments tab from now until the end of the year. So assessment questions, lab reports, and maybe those short quizzes or surveys on Wednesdays. Assessment questions and lab reports are the most important. So there's our assessment question. You can click on it, student view, so we see what you see, and we're back to the same thing. So just go to the Assignments tab, or go to the bottom of the stream to see where it was posted. Remember, it'll always be on 2:30, at 2:30 on Fridays. All right, so a quick review of what the assessment question guidelines are. I'm back in my Physics First Hour class notebook. As you can see in the content library, which is where all our stuff's going to be, I'm in Unit 1 graphing. Obviously, Unit 1 graphing is going to be relevant for the Unit 1 assessment question about graphing. So make sure you're in the right unit. Notes, videos, and demonstrations. I'm in the notes right now, and you can see that in the right-hand content area window. But we're talking about the assessment questions, so at the very bottom, I'll always have assessment question guidelines. On the main page is my flow chart, which looks awesome, doesn't it? And then the subpages are what your paper should look like. So let's make sure we're clear about this. Pick one of these two options. Either make 4 rows horizontally and label each row with the component of the rubric: baseline, visual, quantitative, or qualitative. If you're in physical science, this quantitative is replaced with the math/logic component. Make sure you put your name, the topic. In this case, it would be graphing for physics, or in physical science, the first topic is going to be nature of science, something like that. Forget what I called it in the notes. And the date. Option 2, you put it into quadrants. Name, topic, and date at the top. And then make sure you have the baseline in the top left, visual in the top right, quantitative or math logic in the bottom left, and qualitative in the bottom right. Please make sure you put these particular names there to label each section of the components. And please put them where I'm showing you to put them in these pictures. When everybody does it the same way, it's a lot easier for me to grade. That's the most important stuff on this page. Baseline. So always have each component's description for the unit in here, in these last 4 pages. Baseline, visual, quantitative, and qualitative. So let's review the baseline real quick. The baseline is the first thing you need to score well on so that you can branch off and do the other components of the assessment question. The baseline is always going to ask you about the core concepts, ideas, fundamental theorems, principles, or laws that are relevant for solving that assessment question. All you got to do for this first assessment question in the physics class is what's written here. We don't have any major principles or laws because we're just reviewing graphing. I mean, there are. It's, analytic geometry, but you can just write the principles of graphical analysis will be used to solve this problem. Something like that will work fine. In the future, it'll be something else, like particular laws or theorems you're going to have to know and show how they're relevant to your problem. So for this one, for today, for our very first assessment question, writing one of these things for the baseline will get you those points. After the baseline, you can branch off in any direction, either towards the visual first, the quantitative, or math logic, or the qualitative. It doesn't matter what order you go in. I always like to go with the visual first. It helps me. So the visual for the graphing assessment question is described in this page. For physics, I ask that you show me and label the 5 main types or shapes of graphs that you need to know for this course. If you're not sure exactly what these look like, you can go back and look at the notes, and I have a whole section about that. For the quantitative part, quantitative component for the physics class is going to be about finding the equation of the line that you're given in the problem. So we'll have a linear function, meaning a straight line, and you need to determine what its equation is in the form of y equals mx plus b. So you're going to have to solve for m, the slope, and also b, the y-intercept. Once you know those values, you can substitute the numerical values for m and b into your equation, so you have y equals mx plus b, describing that trend line you're given in the assessment question. Qualitative for the physics class, I'm going to ask you if something changes, how is something else going to be affected? How is it going to be affected, or how is it going to stay the same? Something like that. So the qualitative for graphing is about certain maybe coordinates all being shifted, what would happen to the shape of the graph. This is going to be something you answer with 5 or fewer sentences in English, complete sentences, and you just want to write that down logically. Give me some logical sentences. Again, the quantitative is just the math work. The visual is just going to be labels with these simple sketches of graphs that I asked you to know, the 5 types. And the baseline is basically just to write this. For physical science, let's go to our second hour real quick for physical science. Same sort of setup as the other classes that I have. Content library. Here's our first unit on the nature of science, units, and measurement. This week the assessment question is primarily practice. Make sure we can upload it properly, and it's going to be about the basic kind of nature of science stuff. So I go to my assessment question guidelines. We're in our content library, Unit 1, Assessment Question Guidelines. We have the flow chart to help you see how you're being graded. What your paper should look like, the same as the physics classes, except we call our quantitative math/logic, because sometimes we don't have any math work to do, so we do logic statements. And for this first question in Unit 1 that we're doing this weekend, Friday the 14th to Sunday the 16th, for physical science, your baseline is going to be something like the principles of scientific methodology will be used to answer this question. Because we don't really have any major principles, theorems, or laws at the very beginning of the course. So we're just practicing doing our assessment question. Just write this for the baseline. You'll get your points. The visual. We're going to draw some sort of sketch. In your question, you might be asked, draw a sketch that helps us visualize the scientific method. Maybe that's a flow chart. It doesn't need to be like identical to what's in the textbook. Just show me that you can sketch like a flow chart of what I'm asking for. Scientific method might be one that you get, or I could ask you draw a sketch of a scientific model, like a model of the atom or a model of the solar system. I'm not going to ask you to draw a particular one. I just want you to practice sketching and getting used to having a diagram as part of your assessment. So you'll get either scientific method or just sketch some scientific model you know about. If you don't know about any scientific models yet, I mean, there's an example in the first section of notes and the first section of the textbook, but you could also search for one. Math logic section for physical science. This is going to be a component today, or for, I should say, this question in the unit, our very first assessment question, isn't going to have math stuff in it. We're not doing any formulas or solving equations right now. It's just a logic statement. And the logic statement is going to be an if-then statement. So I paint you a scenario. I paint you a picture of like scientists conducting an experiment. And then I say, if this were to happen, or if the scientists did this, then, and you fill in the rest. What would be a logical conclusion if that thing happened? So like in my examples that you can read here, and which would be, I think, the exact examples or something like that with the questions you're actually going to get. If the scientists didn't maintain their constants, or they didn't use a control group in their experiment, then what might happen? How might the result of the experiment be different? How might the experiment be less valid or more valid? Give me some sort of logical result that you can think of and write out. I say please write the full sentence. Write out the if all throughout, then, and the rest of it. Make it one full sentence. The qualitative for physical science for this week, question 1.1, is just a question of comparing and contrasting. So I'm going to ask you either to compare and contrast independent and dependent variables, or compare and contrast constants and controls. So when we compare and contrast, what I'm looking for is for you to give me some similarities and some differences. So what are some things that are similar about independent and dependent variables? You got to know what they are in an experimental sense so that you can say how they might be similar, and then you also need to understand what they are so you can tell how they're different. Similarly, with constants and controls, if I ask you to compare and contrast, tell me how constants and controls are similar. What's something they have in common? How could you describe them as being similar? And then also contrast them. How are they different? What's different about them? That's it for the qualitative. Okay, everybody, that's it for the assessment review. Remember, your assessment questions can be found in the posts stream at whatever your class is. I'm in Physics First Hour right now, or you can find them up there in the Assignments tab. Don't forget to look in the class notebook to review the assessment question guidelines. They're always there to help you, and they'll always be there every single unit, so you know exactly what I'm looking for each of those components. Have a great weekend. See you next week.